Myself, M. Prasad, working as Assistant Professor in Department of Mechanical Engineering in MBA College of Engineering and Technology. Today we will discuss about cryogenic heat treatment of alloys. So in our previous lecture, we will discuss about different types of heat treatment process. So in different types of heat treatment process, we will learn about so what is the tempering and applications of the tempering and types of tempering one. So what is the hardenability and types of hardenabilities one. So next one is surface hardening, different surface hardening one, and different methods of surface hardening methods. So that is our previous lecture one. Comes to today onwards, we will discuss about cryogenic heat treatment of alloys one. So see here in content, we will discuss about in cryogenic heat treatment of alloys one, introduction. So cryogenic history one, process of cryogenic heat treatment. So application of cryogenic treatment one. So other applications of cryogenic heat treatment. So it is the content one. So here first of all see the introduction. So comes to here cryogenic, the word cryogenic, how we are getting means. So see here the word cryogenic is delivered from the Greek words. So this word cryogenic, this word we are getting on Greek word. So cryo means cold one, and genis means born. So the word cryogenic is literally means the production of ice cold one. So this is the meaning of the cryogenic one. So next one comes to here. What is the definition of the cryogenic? So the cryogenic is the study of the how to attain low temperatures, how to attain low temperature and how materials behave when these low temperatures are attained one. So in cryogenic heat treatment alloys one, we are using the low temperature. So by using the low temperature, we are doing the heat treatment process. So comes to in this low heating treatment process one. So we can observe how the materials are behaved in the low temperature onwards. So that is a major important point for the cryogenic. So cryogenic is defined as the branch of physics and engineering. So cryogenic is the defined as the branch of physics and engineering that study very low temperature, at a very low temperature, how to produce them and how materials behave at those temperature. So at low temperature onwards, how the material are behavior, how the low temperature, how the materials are behave as those temperature. Cryogenics deals with low temperature from about 100 kelvins to absolute zero. So this one we can call as the cryogenic heat treatment of processing. So comes to here single line definition one. Cryogenic is one of the heat treatment process. In cryogenic heat treatment methods, we are using the low temperature. In low temperature onwards, so how the material behaving in low temperature, we can observe. That is the main point here. Low temperature is nothing but how much low temperature we are using means 100 kelvins to absolute zero pressure. We are zero temperature we are using on cryogenic heat treatment procedures. So see here another introduction. Cryogenic is a CT, we can call as a shortcut. So CT is the process of cold treatment below the sub-zero temperature. Is one of the cold treatment one. So below the sub-zero temperature, we are using the cryogenic heat treatment procedure. So see here, it is an expensive permanent treatment one. So it is one of the expensive one and permanent treatment affecting permanent treatment one. So affecting the entire section of the components like coating. So it is one of the inexpensive permanent treatment one. So it is affecting the permanent heat treatment procedure. It is a, so we are using the permanent heat treatment procedure. So it is affecting the entire section of the components. So it affecting, we can see some effects on the entire components, unlike coating one. So it is one of the point. Cryogenic treatment improves the hardness, fatigue resistance, toughness, and wear resistance of the steel work. So the major function of the heat treatment procedure is to improve the hardness, fatigue resistance, toughness, and wear resistance of the steel. So it is using the cryogenic heat treatment process, we improve this type of properties. So this is one of the introduction about the cryogenic heat treatment procedure. So next one we can see what is cryogenic heat treatment one. Cryogenic heat treatment is an ultra low temperature one, ultra low temperature processing of material ones to enhance their desired metallurgical and structural properties. So when cryogenic heat treatment is the ultra low temperature processing of the material one to enhance the desired metallurgical and structure properties one. So in low temperature onwards, we are heating the metal one. Automatically, we are getting the desired metallurgical and structural properties. We are getting one. So that is a point one. So the temperature is about 196 kelvins or 190 Kelvin summa. So degree centigrade to 77 degrees Kelvin summa. So the temperature is about the temperature lies between these two ones. So minimum is 77 degrees Kelvin one. So maximum is 190 degrees centigrade one. So the ultra cold temperature are achieved using the achieved using so computer controls one, a well installed treatment chamber and liquid nitrogen L2 one. So ultrasonic ultra cold temperatures are achieved using the computer controls one. So why? Because so this one we are using in some industries one. So that's why the computer is involved here. So the computer controls a well insulated treatment chamber and liquid nitrogen L and 2 one. So they are completely environmentally friendly. They are completely environmentally friendly ones. So this process is completely environmentally friendly nature, we can observe. So naturally help reduce the waste one. So by using the cryogenic heat treatment process, actually it is helps reduce the waste one. So it is one of the completely environmentally friendly nature we can see in this treatment process one. There is no side effects anywhere. We can use this type of cryogenic heat treatment procedure one. So why means it helps reduce the waste one. That is a major point here. Why we are using this cryogenic heat treatment process means at low temperature onwards we are producing the some properties. What are that properties means? So see here. So we are by using the low temperature onwards we are improving the hardness, fatigue resistance, toughness and wear resistance of the steel. So it is one we can call as one of the cryogenic heat treatment process. And low temperature we are using and improving these properties one. So one of the it is friendly nature atmosphere we can observe on heat treatment process one. So next one is it reduce the waste one. So that is the main concept for the cryogenic heat treatment procedure one. But using the industries, why they are using this type of heat treatment process means these are the reasons. And it is this type of heat treatment procedure also. So next we can see cryogenic heat treatment one. Cryogenic treatment is a one-time permanent treatment process. So we can use it once only. It is one of the permanent heat treatment process and it affects the entire cross section of the materials. So it is one of the permanent method, one-time permanent methods. So it affects the entire cross section of the materials. So usually done at the end of the conventional heat treatment process, but before the tampering one. So before tampering process one, we can use this cryogenic heat treatment process. It is one of the permanent heat treatment process one. So one time permanent method we are using so it affects the entire cross section of the metals. Usually it is done at the end of the conventional heat treatment procedure, but before the dampering one. So the cryogenic process is a modification of the materials. So modification of the materials or components using the cryogenic temperature one. So it is the processing is a modification of the materials. So modification of the materials is nothing but we have some modifications. So brass modifications. So we have some alloy elements. The alloy elements modification when we are modding the alloy elements one. So must ensure this type of process we can use it on that particular material one. Some example of brass. We can modify the brass one automatically. We can use this type of heat treatment procedure. So after then only we are getting this type of properties one. We can get the high strength, toughness and wear resistance also. This type of properties we can getting this type of procedure one. So that is the main concept here. So next one is here process of heat treatment sequence. So first one is we are asking one. We are heating asking one. Next one is quenching one. Next one is aero treatment one. Next one is tampering one. Next one is tampering one. So these are the heat treatment sequence of procedure one. First one is asked tampering, asking one, quenching one, aero treatment one. After the final one is tampering one. So it is sequence of operation one. Classification of cryogenic heat treatments are you can see shallow cryogenic heat treatment procedure SCT, deep cryogenic heat treatment process DCT. So these are the classifications. These two are very important classifications for the cryogenic heat treatment process one. So see here, cryogenic heat treatment procedure. Cryogenic heat treatment procedure of two materials consists of the three stages one. So it consists the cryogenic treatment heat treatment procedure. It consists three stages one. The first stage is cooling of two material from room temperature at extremely slow rate ranging from 0.5 to 1 centigrade for minutes one. So cooling of tool materials. So cooling of the tool material is very important. So cooling, when we are heating and cooling the material one, so we are cooling from room temperature at extremely slow rate ranging from 0.5 to 1 centigrade 1 centigrade for minute one. So in a cryogenic heat treatment process one, at low temperature onwards, we are heating the tool one. After that, what we are doing when we are heating one, after that we are go for cooling one. So in cooling is we are done on the room temperature only. So extremely at slow rate ranging from 0.5 to 1 centigrade for minute one. So cooling also very low we are using one. So temperature also we are using low temperature we are using and heating the metal one, and low temperature are used to cool the tool material one. So that is the major differences between these two ones. So this one, cryogenic, low temperature onwards, we're heating the metal, low temperature onwards, we're cooling the tool materials. So at temperature 0.5 to 1 centigrade, 1 degree centigrade for minutes. So next one is shallow cryogenic heat treatment for the period of minus 84 degrees centigrade one. So we have the two classifications. First one is cryogenic one. So in this cryogenic one, the cooling of the two material is at room temperature we are cooling one. So up to temperature 0.5 to 1 degree centigrade one comes to here shallow cryogenic heat treatment procedure as CT for the period of minus 84 degrees centigrade we are cooling one. So next one is we can see here deep cryogenic heat treatment process DCT for the period of minus 190 degrees 196 degrees centigrade. So minus onwards we are cooling the tool material one. So that is the first one, cryogenic heat treatment process 0.5 to 1 degree centigrade for minute one. Shallow cryogenic heat treatment process we are cooling the tool material minus 84 degrees centigrade one. So comes to next one is deep cryogenic heat treatment process DCT for the period of minus 196 degrees centigrade onwards. We're cooling the tool material. So it is the cooling procedure. These are the three steps, three stages consisting in cryogenic heat treatment procedure. So next one we can see advantages of cryogenic heat treatment process of steel one. So it is one of the heat treatment procedure. By using the heat treatment procedure, so we have some advantages, some practical advantages, heat treatment advantages also we can see here. So cutting tools for different machining operations. So cutting tools. So cutting tools for different types of machining operations, on sawing, milling, drilling, broaching, turning, and shearing. So in cutting tools also, cutting tool operation, machining operation purpose, we can use the cutting tool operation, sawing, drilling. So this type of materials, so we can use it for heat and cryogenic heat treatment procedure work. So metal forming tools, dies, molds, and punches. So these are the one of the advantages one. So high precision parts, gauge, guides, shaft work. So these tools manufacturing purpose also we can use it for cryogenic heat treatment procedure. Parts of high performance, sports cars, engines, and transmissions, crankshafts, connecting rods, piston rings, engine blocks, gear parts, and crankshafts. So these are the applications. These are the advantages of cryogenic heat treatment of steels one. So these are these parts. So parts making purpose you can use it for this type of heat treatment procedure one. Some of the practical advantages see here: delayed punches of new tooling one. So new tooling manufacturing purpose also you can use it this type of heat treatment one. Decreased repair and rework one. So this is one of the practical advantage one. Less schedule downtime to change tooling one. Less schedule downtime to change tooling one. So that is one of the practical advantages one. Lower labor cost. Lower labor cost are used in the heat treatment procedure one. Cryogenic heat treatment procedure one. So this is one of the advantages. See here under applications. What are the applications of the heat treatment procedure? So gun barrels. So increasing wear life of the barrel and making cleaning easier and faster. So gun barrels so increase the wear life. So wear resistance life we are increasing one. So the gun barrels onwards by using this heat treatment process one. So gun barrels we are increasing the wear life of the barrel one and makes the cleaning and easier and faster one. So grinding So in grinding process also we can use it for heat treatment procedure one. So allows a better cut, let's say better finish, and less stringent and residual induced into the workpieces one. So it is one of the grinding application. Grinding process also you can use it for heat treatment, cytogenic heat treatment procedure one. In machining process also we can use it for cytogenic heat treatment procedure one. Lathes, drill bits, cuttings, and milling tools. So next one we can see dental and surgical instruments also. Surgical and dental instruments also instruments manufacturing purpose also you can use it for hydrogenic heat treatment procedure. Next one is engine parts. Some engine parts manufacturing purpose also you can use it for this hydrogenic heat treatment procedure. So it is also one of the heat treatment procedure. So by using this heat treatment procedure we want to change the properties one and structure one. So so after that the material is we are using some of the manufacturing purpose. So one of the manufacturing purpose is nothing but gun barrels. Gun barrels manufacturing purpose you can use it for the heat hydrogenic heat treatment material one. So grinding purpose also you can use it for hydrogenic heat treatment material one. And machining comes to machining one. Machining is lathe, drill bits, cutting and milling tools. So dental and surgical instruments. This type of tools also this type of tools are manufactured for hydrogenic heat treatment materials one. So next one is engine parts. Engine parts also we are made for some of these hydrogenic heat treatment materials one. So these are the hydrogenic heat treatment procedure. Hydrogenic heat treatment procedure one. So it is also one of the heat treatment procedure one. Comes to heat treatment procedure, centrally we have the few classifications. First one is handling, normalizing, hardening, tempering, hardenability. So surface hardening one. In surface hardening also we have the different types of classifications. So that total topics we will discuss about in our previous lecture. So it is the hydrogenic heat treatment procedure. So next one we can see another topic one, new topic one. So next one we can see triple D one. First comes to here hydrogenic heat treatment procedure conclusion one. So hydrogenic hardening is a permanent non-destructive or non-damaging procedure one. So it is a permanent non-destructive and non-damaging procedure. Why? Because so in this one we are using the less temperature we are using one. So less temperature we are using, so that's why we cannot see the damages on the this particular procedure one. So why? Because low temperature onwards we are increasing the properties one. So that is the major advantages for this type of heat treatment procedure one compared to another procedures. Another procedures also we have handling, normalizing, tempering, hardening, surface hardening also. But on the particular that type of heat treatment procedure we are using the higher temperature we are using one. But in this particular in this hydrogenic heat treatment procedure we are using the low temperature. Low temperature onwards we are changing the properties one. So that's why it is one of the permanent and non-destructive and non-damaging procedure. It is which reduce the abrasive wear and relieves the internal stresses one. Which reduces the abrasive wear and it relieves the internal stresses on the material one. So any one material, the internal stresses also we are removing on hydrogenic heat treatment procedures. Minimizes the micro cracking due to these shock forces. Minimizing the micro cracking. Cracks also we can observe. Why? Because so when we apply the high load on the material one, so automatically some cracks we can see on the particular material one. So the cracks and due to shock force also we are minimizing one. So comes to here lengthens parts life and increasing performance one. So length ends parts life and increasing the performance one. So the parts length, so length means lathe machines we are using the some of the parts one. But using the hydrogenic heat treatment materials are used to manufacture the some of the so lathe parts one. So spare parts one. So the parts are we are increasing the performance. So automatically hydrogenic heat treatment procedure. So we are giving the perfect properties to the material one. Automatically, what happens? Performance will be increasing. So why? Because we are getting the desired properties. We are getting one. Automatically, the performance of the material is very good one. The properties are not in good way, not in perfect one. So what happens? The performance of the material is very low. That is a major difference here. So the properties are very important one. Why? Because we are getting the requirement properties we are getting on the particular material one. So automatically the performance of the material is very good. So based on the requirement one, we are not getting the good properties on the material one. So automatically the performance is very low about the particular material. Why? Because you can see the some damages. So some drawbacks on the particular material one. So that based on the our requirement one, where we are using the particular material one. So on the particular material onwards, you can see the some some analysis we can see on the particular material one. So this is the conclusion one. So next topic we can see heat treatment procedure, triple T, time temperature transformation diagrams. So see here. So this is one of the very important topic, one of the very important topic, especially for heat treatment procedures. So see here, other end, on the other hand, triple T diagrams, time, temperature, transformation diagrams. So simply we can call as triple T diagrams. So triple T diagram is the more practical diagrams. This is a more practical diagram. Practical means in practical one. So experiments we are doing one. Experiment is nothing but so any industries we have some production industries. In production industries we can see the so parts, spare parts manufacturing industries. The spare parts manufacturing industries by using the metals that manufacture the some of the tools, some of the small parts one. So in this particular one, in particular the production one, we can observe, we can do the practice on the this type of diagrams one, triple T diagrams, time, temperature, transformation one. The types of production one is one of the very important diagrams. That industries, it is the one of the very important diagram. Why means time, temperature based on the transformation is done. Why? Because when the temperature we are increasing one, based on the time one, the transformation is changing one. So phases are changing one. So 0 degrees onwards, we can see the one structure one. So one transformation we can see. So 100 degrees centigrade onwards, we can see the another transformation and structure will be changing one based on the time. We can see the time 0 degrees onwards, we can see the zero no time. 100 degrees onwards, we can see the 50 seconds. 200 degrees centigrade onwards, we can see the 1 minute one. So 300, 3 minutes, 4 minutes. When the temperature will be increasing, time also increasing, one transformation also changing like this. So this one we can call this time temperature transformation diagrams one. So see here, it shows the structure can be expected after various rates of cooling one. So the structure can be expected after various rates of cooling. So when we are cooling the metal one, automatically we can see the various structures. So first, initially we have the one structure one. So when the solidification will be starting one, we can see the one structure. When the solidification is middle one, we can see the one type of structure. When the solidification is the end one, we can see the other structure. So that is a major point in here. Next one is the graphical describe the cooling rates required for the transformation of austenite to perlite, bainite or martenite. In graphical describe the cooling rates. So in this graphical representation of triple T diagram, the transformation of austenite to perlite. So the transformation you can see on triple T diagram, austenite to perlite, bainite or martenite. So you can see this type of transformations you can see on triple T diagram. Triple T diagram also gives the temperature at which such transformation takes place. Triple T diagram also gives the temperature. It gives the temperature at which transformation takes place. And for the transformation changing purpose, we can give the temperature also. Based on the transformation onwards, we can see the temperature, how much temperature onwards the transformation is going on. So it is the introduction about the triple T diagram, time, temperature, transformation one. So transformation diagrams, there are two mainly types of transformation diagrams that are helpful in selecting the optimum the steel and processing route to achieve their set of properties. So based on the requirement one, so we can choose this type of diagrams one. So what are the two main transformation diagrams? Means first one is time temperature transformation, triple T one. Continuous cooling transformation one, continuous cooling transformation one. So it is another method diagram one. So based on the requirement one, we can select this type of diagrams. First one is triple T diagram. Second one is double CT diagram, continuous cooling temperature cooling transformation diagrams one, continuous cooling transformation diagrams one. So triple T is nothing but time, temperature, transformation diagrams. So see here these diagrams introduction one. So first comes to see here triple T indicates the amount of transformation at a constant temperature. At constant temperature, it indicates the amount of transformation. Amount of transformation is nothing but, so before onwards, the composition we are taking 100% work. So at constant temperature onwards, how the transformation is going on. Some example 100 before heat treatment, before this diagram, triple diagram. So the composition is 100%. When we start this triple diagram onwards, so what happened at constant temperature onwards? What happened? The composition will be transformed. So 100 to how much? So 70 it is increasing or reducing. You can see the variation on this diagram one, triple diagram one. So samples are austenite and then cooled rapidly to a lower temperature and held that temperature. Slit amount of transformation is measured. For example, by dialometry. Samples are austenited and then cooled rapidly. So when we are taking austenite temperature and cooling one rapidly, we are cooling one set lower temperature onwards and held that temperature, visible amount of transformation is measured one. So at austenite temperature onwards, we are cooling the metal one. Automatically, we can see the some amount of transformation we can see on the particular austenite temperature. Austenite temperature onwards, while cooling the metal one, automatically we can see the some of the transformations. The transformations are changing slowly one. So step by step onwards, they are changing the transformation one. So that is the point here. Absolutely, a large number of experiments are required to build up a complete triple-T diagram. Obviously, a large number of experiments. So finally, how can we get the triple-T diagram? Means obviously a large number of experiments are required to build up a completely triple-T diagram. Complete when we are complete the triple-T diagram means obviously a large number of experiments are needed for the triple-T diagrams. So after then only that successfully we can see the time temperature transmission diagram. So it is a major concept for the triple-T diagram. Next one we can see continuous cooling transmission one. So double CT, continuous cooling transmission one. So indicates the extension of transformation as a function of time for the continuous decrease in the temperature one. So it is indicates the extension of the transformation as a function of time for the continuous decrease in the temperature. At a certain temperature onwards, see here, when we are reducing the temperature, automatically we are cooling. We are cooling the metal. Automatically, we can change the. We can see the some changes. Some changes we can see on the particular procedure. How means when the temperature will be reducing one, automatically what happens? The transformation will be changing. So how the transformation will be changing means solid becoming the liquid becoming solid one. So the solidification starting from some temperature onwards, the solidification begin at particular temperature and end with a certain temperature. So solidification start with some example one 600 degrees centigrade onwards, the solidification will be start 200 degrees onwards, the solidification will be ended one. Before starting and ending onwards, we can see the transformation of the material one. Must should so each and every degrees. So each and every degree centigrade onwards, the transformation will be changing one. So it is the cooling diagram one. So when the metal become liquid to solid one, that is the cooling one. So heating a triple T onwards, so triple T time temperature transformation onwards, so we can see the variation triple T diagram, but it is especially continuous cooling transformation one, cooling one. That is the first point here. So samples are austenite and cooled at a T-determined rate, and the degree of transformation is measured one for extremely dialometry one. So see here, austenite temperature onwards, we are cooling the metal one. Automatically, we can see the sum of the transformations. So some of the transformations in this few minutes back, I can say that one. So when the temperature will be reducing one, automatically the structure and the composition also changing one, and properties also changing one. These three are very important one. When we are cooling the one metal one, automatically the composition will be changing, the cooling procedure one, properties will be changing one, structure also changing one. These three functions are we can see on the solidification procedure are cooling one, continuous cooling transformation onwards. So when one metal we are cooling one, so automatically what happens? So each and every degree centigrade onwards, you can observe transformation will structure will be changing one, properties will be changing one, composition also we can change one. So that is a major point here. So some example they can say arsenic one. So in this case also a large number of experiments are required to build up a complete double CT diagram. So in this completely diagram, how we are getting double CT diagram means, so a large number of experiments are required to build up a complete double CT diagram one. So continuous cooling transformation, how we are getting means, so a large number of experiments are required to build up a double CT diagrams. So it is our today class, Amma. So on this today class, we will discuss about, so first topic is cryogenic heat treatment, alloys one. So cryogenic heat treatment is one of the heat treatment procedure one. So by using this heat treatment procedure one, so in heat treatment procedure we are using the low temperature. Low temperature onwards we are heating. By using the low temperature onwards we are heating the metal, and we are getting this, or we are improving the some of the properties. So see here, at low temperature onwards we are using in this process, and at low temperature we are using and improves the hardness, effective resistance, toughness, and wear resistance of the steel one. So it is one of the very important procedure for the cryogenic heat treatment of procedure one. But using the at low temperature onwards, we are heating the metal one. Automatically, we are getting this type of properties one. So it is one of the very important heat treatment procedures. Why? Because so it reduces the waste one. So by using this one, we reduce the waste one. It is a friendly nature heat treatment procedure one. So that is the major reasons why they are prefer for this type of heat treatment procedure, means reduce the waste one. Why? Because they reduce the waste one, automatically it is one of the good advantages for the industries one, and simultaneously it is one of the friendly atmosphere we can see on the this type of heat treatment procedure also. So what are the applications? Means cryogenic heat treatment process, we are using the low temperature onwards, we are heating the metal and cooling one. Finally, we are getting the different types of properties one. So after then, the final materials are used to manufacture this type of parts one. So gun barrels we can manufacture by using the cryogenic heat treatment metals are used to manufacture grindings one. In grindings one, see here, allows to better cut, less better finishing one. So grinding, why you can use means this is the definition one. So machining also, in machining process also we can use it for cryogenic heat treatment materials, lathes, drill bits, cuttings, and milling tools. So next one is dental and surgical instruments parts also. By using the cryogenic heat treatment metals are used to manufacture dental and surgical instruments also we can manufacture. So on engine parts also we can manufacture engine parts by using this metal to manufacture engine parts also. So these are the cryogenic heat treatment procedure. So next one is the triple T one. So it is the conclusion one. So this is the triple T diagram one. So triple T, time, temperature, transformation one. So time, temperature, and transformation diagrams. Generally we have the two methods. The first one is triple T one. Second one is double CT. So triple T is nothing but time, temperature, transformation one. So double CT is nothing but continuous cooling transformation one. So it is the today class. Thank you, Amma. So it is our last topic. Next class, detailedly we will discuss about triple T diagram and double CT diagram. So it is one of the last topic for the heat treatment of alloys. So thank you, Amma.